have this piece function, f of x, and I have two rules. So I have two different equations for these restrictions. What are we going to do? We are going to evaluate each rule at that restriction. So my first equation was negative 2x plus 4. So when x is 2, I will have, okay, let's write it below, negative 2 times 2 plus 4. This gives me 0. Now I am going to evaluate to the left of 2. Why to the left of 2? Because the symbol is pointing to the left. So a point that is to the left of 2 could be 1, could be 0, negative 1. Let's work with 1. 1 is to the left of 2. So when x is 1, I have negative 2 times 1 plus 4. This negative 2 plus 4 give me 2. So now, at the boundary, I don't have an equal. So this 2, 0 is going to be an open circle. So 2, 0, I have an open circle. Now, I went to the left, right? I went 1 unit, that gives me 1. So when x is 1, y is 2. And we connect, and we are going to have this line. So it goes to the left forever and ever. You see that also I could have used the y-intercept, b, 4. Now let's graph the second one. So this is the top equation. The bottom equation, the bottom rule says x minus 1. Again, I have to evaluate at the boundary when x is 2. So I have 2 minus 1, 1. So y is 1. This is a closed circle. Why is it closed? Because I have an equal in the inequality. It's included. Now I need to evaluate where, to the left or to the right. Look at the symbol. The symbol is pointing to the right. So I'm going to choose a point to the right of 2. To the right of 2 is 3. And I plug it in. So when x is 3, 3 minus 1, 2. I am going now to plot this point. So first a closed circle at the boundary. When x is 2, y is 1. And I have another point, 3, 2. I will connect. And I have this portion of my piece function. We have another piece function, g of x, and now I have 1, 2, and 3 rules. And I have restrictions at negative 2 and restrictions at positive 2. This means there is going to be a change where x is negative 2, that something is going to happen when x is 2. So let's figure it out. We need to evaluate at the restrictions. So the first equation, negative x, I am going to evaluate when x is negative 2. So I'm going to evaluate when x is negative 2, y will be positive 2. Good. Now, there is an equal. So this is going to be a closed circle. So when x is negative 2, y is 2, I have a closed circle. Now I need to evaluate to the right or to the left. Look at the symbol. The symbol is pointing to the left. So I am going to evaluate a point that is to the left of negative 2. Let's do negative 3. So when x is negative 3, this will be 3. So negative 3, 3. And now I am going to connect these points to have my segment. And there it is. So we finish with the top rule. Now we move to the second one. The rule says 2x minus 2. I will evaluate at the boundaries when x is negative 2, boundaries or restrictions. So when x is negative 2, let's do it below. 2 times negative 2 minus 2, negative 4 minus 2, negative 6. Good. Now I need to evaluate the other end. 2 when x is 2. So I will have 2 times 2 minus 2. This gives me 2. So I plot my second point, and now let's see open or closed. I see that at both restrictions is open. There is no equal. So I will use open circles. So when x is negative 2, this gives me negative 6. I have an open circle. And the other, when x is 2, y is 2. I will connect these points. And now I need to do the third rule. 3. This is a constant. The constant function is just a horizontal line. So, but this is to the right. How do I know? Because the symbol is pointing to the right. So to the right of 2, y is 3, okay? I have this point, and it's going to be closed. And I'm going to go to the right. And this is my graph for this piece function. So we can evaluate. You choose. Remember, look at the symbol. This symbol, you evaluate at the restriction, and you are going to the left. So choose a point to the left. This is between these two. So I'm going to evaluate at the restrictions and connect these points. This function is to the right. I evaluate and go to the right. In this case, I didn't need to evaluate because it was just a constant. I hope this is useful. Good luck.